Hello viewers, welcome to this video lecture series on analysis and design of algorithms. In this session, I shall discuss on n-queens problem. Before I tell you in detail about what is n-queens problem and what is the solution to n-queens problem, you should be knowing these terms: backtracking and state space tree. So what is backtracking? In order to solve the n-queens problem, you are using the approach that is the backtracking approach. What do you mean by backtracking? Backtracking is an approach in which you are going to find the solution to the problem, and if that current solution is not suitable, then you backtrack and try to find if other solutions exist. And this backtracking you need to represent using a tree, and the tree is called as the state space tree. This state space tree is going to represent all the possible states of the problem, and the initial state is the root. Okay, it is represented as the root because you are going to show the different states of the problem starting from the root level. So that root state is called as the initial state, and it will go up to the leaf level of the tree, and that leaf level is the terminal state. And in this state space tree, you will come across two types of nodes: promising node and non-promising node. A node in a state space tree is said to be promising if it corresponds to a partially constructed solution that may still lead to a complete solution. Otherwise, it is called as non-promising. So the different nodes that are there in the state space tree, those nodes, if they lead to a complete solution, then you call those nodes as the promising nodes. Otherwise, you call them as non-promising nodes. Leaves of the tree represents either non-promising dead ends or the complete solutions found by the algorithm. So let us see first the n-queens problem here. What exactly is the problem and how you are going to use the backtracking approach in order to solve this problem. N-queens problems, you need to place n queens on a chessboard in such a manner that no two queens should attack each other. Suppose if you take n equal to 4, then on the chessboard you will be having 4 by 4, 4 into 4, 16 cells, and you are going to place the queens, 4 queens, q1, q2, q3 and q4 in such a manner that no two queens should attack each other. The queens will attack each other if they are placed in the same row or in the same column or in the same diagonal. So you need to avoid these three. You should not place in the same row more than one queen. You should not place in the same column more than one queen. You should not place in the same diagonal more than one queen. Suppose if you are placing q1 here, if you place q2, then we say q1 and q2 can attack each other. So this is not allowed. Suppose if you place q2 here, even then we say queens can attack each other because they are in the same diagonal. Suppose if you place q2 here, even then we say queens will attack each other because they are in the same column. Suppose if I am giving the column numbers as 1, 2, 3, 4 and row numbers as 1, 2, 3, 4, you have to place q1 here. q1 if you are placing here, we will talk only in terms of rows. If we try to place q1 in the first row, then q2 should come in the second row. The moment you try to say that q2 is in the second row, but you should not place q2 in the same column, so it should be in a different column. So you can place q2 here. So q2 if you place here, then once again you need to check whether they are diagonally placed, whether they are in the same diagonal. So definitely these two queens can attack each other, so you cannot place q2 here. You have to place q2 in this column. So likewise you have to select properly the column for q3 and q4. Let us solve this problem using the state space tree. For n-queens problem, we'll take n equal to 4. That is, we are going to solve the 4 queens problem here. And in 4 queens problem, to place 4 queens on a 4 by 4 chessboard, let us keep ready the column numbers and the row numbers 1, 2, 3, 4, 1, 2, 3, 4. Now, in order to start with the first queen, as per the rules, every queen has to be placed in one row. So, first queen q1 in the first row of the first cell, we will place it here. Parallelly, we'll sketch the state space tree. This is the root node which is specifying the initial state of the state space tree. From the root node, now we should start placing this q1, whether it can come into the first cell, second, third and fourth. We know that q1 can be placed either in the first column of the first row, second column of the first row, third column of the first row or fourth column of the first row. So all 4 possibilities we can show it here. Q1 can be placed in the first column, Q1 can be placed in the second column, Q1 can be placed in the third column, Q1 can be placed in the fourth column. Now, since we have placed Q1 in the first column, we'll extend that part of the tree and we'll see whether Q2 can be placed. See, whatever I am writing here, the first level indicates that we are referring to the first row. First, we have to start with the Q1 getting placed in the first column, this part of the tree. Then next we have to check whether Q2 can be placed in the second row, and we have to decide in which column of the second row it has to get placed. Now suppose if I am placing Q2 here, I cannot place it because Q2 will fall in the same column. If I place Q2 here, this is also not allowed, diagonal same. Q2, can I place it here? Yes, I can place it here. There is no clash from Q1. And Q2, can I place here? Yes, you can place. So I have these two options for Q2 to get placed. So those two options I can show it in the state space too. Out of these four options available in the second row, Q2 in the first column of the second row, Q2 in the second column of the second row, Q2 in the third column of the second row, Q2 in the fourth column of the second row. Out of these four options, so we can say these two we cannot place. So for us, the next option left is this one, Q2 equal to 3. So we started with Q1 equal to 1. Now we are here, Q2 equal to 3. Now after placing, because when you start from column number 1, 2, 3, the next in the serial order is 3 only. So for Q2 equal to 3, we'll decide. Next we will try to place Q3. Q3, can you place it here? It is in the same column, not allowed. Q3, can you place it here? Diagonal same, cannot allowed. Q3, can you place it here? Not allowed because it is falling in the same column. Q3, can you place it here? Not allowed because it is diagonal same. So all four options in the third row for Q3 is not at all possible. So those four options we have to show it here in the state space tree. Q3 in first, Q3 in the second column, Q3 in the third column, Q3 in the fourth column. So all these four positions we have seen, it is not possible. Then what we need to do is, since it is not possible for us to place Q3 in the third row, and we'll go back to the second row and try to see whether we can select the other option for Q2. Because Q2 we have selected the third column. Now we'll see whether we can select the fourth column. So we are trying to change the position for Q2 now. So for that reason only we say here the backtracking is taking place. We tested here for Q3 equal to 1, Q3 equal to 2, Q3 equal to 3, Q3 equal to 4. All four options are not possible. That is why we will move back. That means when we tested here for all the four options, we have to move back to the previous row. So we'll change Q2. Now for Q2, we have only one option remaining, that is Q2 equal to 4, this one. After you place Q2, then you will start for Q3. Q3, can you place it here? Not possible because it is falling in the same column. Q3, can you place it here? Q3, yes, we can place it here because there is no obstacle from Q1 and Q2. So first we will show here Q3 equal to 1. Okay, this was the option for us, and the other option is, we have actually four options. Out of that, which one is possible, that we need to check here. So we have seen here Q3 in the first row, first column of the third row, Q3 we cannot place it here. So we will, Q3 cannot get placed here. So we will put, and next we have seen that Q3 in the second column is possible. So we'll check for this row. Now we have to see whether we can place Q4 in the fourth row. Now we are here in this path. Now we have to go for the Q4. Have the options Q4 equal to 1, Q4 equal to 2, Q4 equal to 3, and Q4 equal to 4. Now out of these four options, we need to check where we can place Q4. First we will check here Q4. No, it is not possible. It is lying in the same column. So this option is not possible. Q4, can we place it here? No, it is in the same column. So we cannot place it here. Q4, can we place it here? It is in the same diagonal. We cannot place it. So this also is not included. Next we have one more option, whether we can place Q4 here. It is in the same column of Q2. We cannot place it. So for us, all the four options here is not possible. Then we need to backtrack. So once we backtrack, that means from this fourth row we are coming back to the third row. If I'm coming back to the third row, then in the state space tree I should go to this node. Fine, I am coming back to this node and checking whether q3 equal to 3. That means if I change the position for q3 here, look at the chessboard here. If I am changing the position for q3 from the second column to the third column, then we will try placing q4 in the fourth row. So now we'll come back. So from here we have backtracked and select this position q3 equal to 3, and then we will check for q4. So first in the chessboard we'll show that position q3 equal to 3. So q3 equal to 3, then next we have to check now for q4. q4, can you place it here? Not possible, it is in the same column of q1. q4, can you place it here? Not possible, it is in the same diagonal. q4, can you place it here? Not possible because it is in the same column. q4, can you place it here? Not possible, it is in the same diagonal. So all four options are not possible here when you tried the fourth row for q4. Those four options we need to show it here. So we have seen just now it is not possible, all these options. q4 equal to 1, q4 equal to 2, q4 equal to 3 and q4 equal to 4. All these options are not possible. For us, once again we need to backtrack. Now we'll try placing q3 here, but when you try placing q3 here, it is not possible because it is falling in the same column. So q3 in 4 is not possible, this part, so we can put a cross here, this is not possible. Then we need to backtrack. So previously we have carried out the backtracking here. Now once again backtrack it and go to the previous row. So when we tried placing q3 in all these positions, it is not possible. Then we will move back to the second row. Now we have to think of q2 position to get changed, but q2 already we started from the first, second, third and fourth. So q2 has covered all the options. So once again we have to backtrack and check whether we can change the q1 position. So q2, as I said already, we have tested q2 equal to 1, q2 equal to 2, q2 equal to 3, q2 equal to 4 also we tested. Now no more options remaining for q2, so we need to backtrack. So when we backtrack, we are reaching the root node, and from the root node we can now select q1 equal to 2. So we are now changing the position of q1 only. See, q1 equal to 1 is this one in the state space tree. From q1 equal to 1 we have explored these many options. Fine. Then we have come back to the root node. Now we are trying to change q1 equal to 2. So we'll place q1 in the second column. Now we'll test for q2, second row. q2 not possible, it is in the same diagonal. q2 not possible in the same column. q2 not possible here, it is in the same diagonal. q2, can you place it here? Yes, you can place it. So q2 equal to 4, we can place it. Three options not possible also, will show it here. This was not possible, q2, this is not. Now we are here, so we'll check from q2. Now we'll see for the next row, q3. q3, can you place it here? Yes, we can place it because there is no obstacle from q1 and q2, so we can show that in the state space tree. q3 equal to 1. So once we are having no problem with q3 equal to 1, we need not explore the next three columns. So q3 equal to 1 is decided. Now we will decide the position for q4. q4, can you place it here? Not possible because it is in the same. q4, can you place it here? Not possible, it is in the same diagonal. q4, can you place it here? Yes, there is no problem at all because no obstacle from q1, q2 and q3. So this position for q4 is finalized. The previous two which we have checked, for that we have to show it in the state space tree that it is not possible. q4 equal to 1 was not possible, q4 equal to 2 was not possible. Now we can we have explored, we have checked this. q4 equal to 3 is possible. We are able to place all the queens in the correct position now. So this is the final position for all the 4 queens, q1, q2, q3, q4, and that you can see in the state space tree, this path. q1 equal to 2, q2 equal to 4, q3 equal to 1 and q4 equal to 3. This is the solution. So this solution, I'll just highlight that path. q1 equal to 2, q2 equal to 4, q3 equal to 1 and q4 equal to 3. So that solution column numbers, I'll write it here, 2, 4, 1, 3. Definitely each one is taking a unique row. The column numbers are 2, 4, 1, 3. If I am writing 2, it indicates second column of the first row, fourth column of the second row, first column of the third row, and third column of the fourth row. This is the solution. Now this is one thing, but still one more thing you observe. For this root node, we have q1 equal to 3 also and q1 equal to 4. We have not explored these two because in backtracking, when we are using the approach backtracking, there is a possibility of having multiple solutions. We have come across with one solution 2, 4, 1, 3, but we also need to check whether we can have one more solution for this 4 queens problem. For that, we will come back to the root node and start exploring this path now. This path, if I am exploring, that means I have to place q1 in the third column. So I am placing q1 in the third column. Now if I am placing q1 in the third column, can I place q2 here? Yes, we can place it, no problem. So I can write it in the state space tree, q2 equal to 1. Can I place q3 here? Not possible, it is in the same column. q3 not possible, in the same diagonal. Can I place it here in the same column? Not possible. q3, can I place it here? Yes, we can place it here because there is no obstacle. So what I have to do is, for q3 I have to show that these three options are not possible and this option is possible. These things I have to show it in the state space tree. Previous level, if you observe, q2 we started with q2 equal to 1. Okay, since this was the first column, so we need not write the options for second, third and fourth in the state space tree. Now since already we have decided the position for q2 equal to 1, then the remaining three options we are not writing in the state space tree. Next we started checking for q3. q3 first, second, third, three positions were not possible. q3 the fourth position is possible. That is why we have to show in the state space tree the previous positions that were not possible. So now I will write it here, all the three positions. q3 equal to 1, q3 equal to 2, q3 equal to 3, and you have now q3 equal to 4. So q3 equal to 4 is possible in loss. Now from q3 equal to 4, we should proceed for q4. So we will proceed for q4 now. q4, when you tried placing here, not possible, in the same column it is. q4, can you place it here? Yes, we can place it because there is no obstacle from q1, q2 and q3. So this position, so only the previous one position we have to show in the state space tree that it was not possible. q4 equal to 1 was not possible, whereas q4 equal to 2 is possible. This is the solution 1. Solution 2. So we got one more solution and the path is this one, q1 equal to 3, q2 equal to 1, q3 equal to 4 and q4 equal to 2. I'll highlight this path. So we got now the second solution for the 4 queens problem. So I'll write down the column numbers here, 3, 1, 4, 2. So it means what? Third column of the first row, first column of the second row, fourth column of the third row and second column of the fourth row. This is the second solution. So you can write here, this is the solution 1, this is the solution 2. And if you observe the positions in the solution 2, 3, 1, 4, 2, whatever you got, it is exactly the mirror image of the solution 1. Now for us, only option left is q1 equal to 4. This one we need to explain. What if q1 is placed in the fourth column? Because see, what we have done in the 4 queens problem is we started q1 placing from the first cell onwards. q1 we tried placing here, we did not get any solution. q1 when we placed in the second column, we got the solution as 2, 4, 1, 3. q1 we placed in the third column, we got 3, 1, 4, 2. Now we are having only this one option left. Suppose if we place q1 in the fourth column, do we get one more solution or not? That we need to check here. So that is called backtracking. From every time we are coming back to the root node and checking for all the possibilities. So I'll make one more board and show you those things. So q1 we are placing it in the fourth and we are showing it here in the state space tree, q1 equal to 4. Now for q2 we should start checking q2 here. Can you place it? Yes, you can place it. q2 equal to 1. Then next q3. So from q2 equal to 1, we are checking for q3. q3, can we place it here? Not possible. Here, not possible. Here, can we place it in the third? Yes, we can place it. So q3 in the first and second column are not possible. Third is possible, that we need to show in the. So q3 equal to 3. This is not possible. q3 equal to 1 and q3 equal to 2. Now from q3 equal to 3, can we place q4? Here q4 not possible in the same column, same diagonal not possible, same column not possible, here not possible. So q4 options, we don't have any option left for q4, but only option is when we backtrack, when we change, can we change the position for q3, that we need to check. So now we'll change the position for q3. There we can change the position for q3 to the fourth column from here to here. So here if you try to place, you can see it falls in the same column of q1. So it is not possible. And next option left is what we need to backtrack and check for q2. q2 we are here. Okay, q2 if you try to place it here, fine. Then what will happen? Suppose if you place q2 here, then you start placing q3, not possible, not possible, not possible, not possible. Then for us option remaining is q2, can you shift it here? Not possible, because this is giving a clash here. Then q2, can you shift it here? Not possible, this is clashing with the same this is clashing with q1. So q2, all 4 options we have checked, it is not possible. Then when we backtrack, q1 already we have carried out for 1, 2, 3, we were doing it for 4 now. So all possibilities when we tried for this, when q1 is placed in the fourth column of the first row, it is not possible to place q2, q3 and q4. So this is not going to lead us to a solution. So I can show here, okay, not possible for q1 equal to, q4 equal to 1, q4 equal to 2, q4 equal to 3 and q4 equal to 4. So this way what we found is there are 2 solutions for the n queens problem. Solution 1, 2, 4, 1, 3. Solution 2, 3, 1, 4, 2. So I'll just indicate with different colors the nodes that are present at each level. First, so we can see that in the state space tree, the 4th level trees are indicated with this brown color, 3rd level with the magenta color, 2nd level with the red color, and the 1st level nodes are indicated with the blue color. So this is how you need to solve the 4 queens problem. The time complexity for the n queens problem is we go of n factorial. See, for the first row we check all the n columns, but when you go for the second row, you are checking only n minus 1 columns. You started with 4 columns, then in the second row you are checking for 3 columns, and for the third row you have the option only for 2 columns, and for the fourth row you have the option left, that is only 1 column. So as you move from the first row to the second row, the number of columns get reduces by 1. That's why we are writing here, for the first row we check n columns, for the second row we check n minus 1 columns, and so on. So the time complexity will be what? N into n minus 1 into n minus 2. That's why the time complexity for the n queens problem is we go of n factorial. And not only, and for the space complexity of n queens problem is we go of n square. Applications I have mentioned here. 4 queens just now we have seen, there are 2 solutions. So for 5 queens we have 10 solutions, and for 6 queens we have 4 solutions. For 8 queens we have 92 solutions. Hope you find this helpful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.